Let's think about first order system next. We have already looked at the zero order system. The first order system equations are given as shown in the screen here. So that in the time domain, the relationship is shown here. So a1 dy over dt plus a naught y will be equal to b naught x, right? So in addition to the terms that we had in the zero order system, which was a naught y, we have another term which is the first differential of y. Now, if you convert this differential equation into a frequency domain representation and you write y over x in the frequency domain, you get uh, this equation here, where k is the static sensitivity which we saw before in the zero order system, but we have another parameter for describing the behavior of the first order system, and this parameter is the time constant tau here, right? So for to describe the first order system you need two parameters, the static sensitivity and the time constant. Now, I think the easiest example to think about for a first order sensor would be a thermometer, a mercury column thermometer. So again, I'm going to use my pen here. So imagine this pen is a thermometer. Okay, so this is the mercury bulb, and this is the column which the mercury would climb up as the temperature is increased. Okay, so now let's say what you do is you have your mercury thermometer at room temperature and you suddenly put it in boiling water. So I've just put it in boiling water. So what is going to happen to the mercury column? Is it going to rise suddenly at the same speed at which you change the temperature? No, right? It's going to take some time. The mercury column is slowly going to go up and reach the final value. And it's going to take quite some time to do that. In fact, if you have ever used a thermometer to measure your body temperature, it takes you are supposed to keep the thermometer in your mouth for around a minute or so. So it takes a long time, and I think that is a good description the of a first order system. So let's look at how a first order system behaves when we give it different kinds of inputs. So here what we are doing is we are giving to this first order system a very sudden input. So think of it like as if you're taking a mercury thermometer and suddenly putting it into boiling water. What happens to the output? The output does not change suddenly as in a zero order system, but it slowly rises, and it keeps rising till at some point it reaches the final value. And depending on the time constant of your sensor, the rise can be fast or it can be very slow. So if your time constant is large, you will have a large uh, time to reach the final value, and if your time constant is small, then you will reach uh, the final value quicker. The time constant is basically the time it takes for the sensor to reach 63% of its final value. Now you can now if you look at the frequency response, so in the frequency response, just to remind you again, what are we doing? We are giving a sinusoidal input. So in this case, if you take a temperature sensor, what we are doing is we are giving a sinusoidal temperature. So imagine this mercury thermometer being in a water bath, and somehow you're changing the temperature of the water bath in a sinusoidal shape. So what would the shape of the mercury column look like? Now, if the temperature of the water is changing very, very slowly, then what you would expect is that the mercury column would just go up very slowly because the input is changing very slowly, and then come down very slowly. So basically, it's able to follow the input. But if you increase the speed of the change of the input, okay, of the temperature, what would happen? The mercury column would try to follow the input. It would just go up a little bit, but before it's reached its final value, the temperature has already changed and it's gone down. So the mercury column would go down. But before it reaches down, again, the temperature of the water bath has changed and it's gone up. So it will try to go up. And therefore, it won't be able to really follow the input. And that's what you can see in this curve. At low frequencies, you have a gain of 1, which means that the input is the output is following the input quite well. You're able to measure it. But as you increase the frequency, the gain starts to fall down. So the mercury column is not really able to keep track of the input. So that's a first order system.